Hi, here's a do-it-yourself power supply that you can build for about 20-25 bucks maybe, and you can do it in about like 30 minutes, which is what it took me to build this one. It works on an external plug pack of any voltage, and I just built it into a case that I had lying around, had some binding posts lying around, and it's a little cute little bench power supply, and it can do 0 to 20 volts output up to 0 to 2 amps, constant current and constant voltage, and it's got this neat display here that basically shows you all the current and output power. And the interface here, a nice little multi-line LCD that shows the set voltage, the output voltage, the set current, the output current, and the power, and some preset voltages. There's an on-off button here, which is not on its output on-off. There we've got ourselves a selection knob, and if we switch it on here, it's got constant, we see we're in constant voltage mode, and we've got an output voltage of 5 volts and an output of 0.99 amps, and that matches our load up here precisely. Beauty. So how do you build one of these puppies for like $20 odd and build it in 30 minutes? Well, you might have guessed that this module is a complete off-the-shelf module. This is not a kit. I'll open it up and show you that there's virtually nothing in here except, ta-da, this little module here that you can buy on eBay, AliExpress, or whoever. I'm not actually sure who manufactures this, but it's a very cute little module that we'll take a look at, and there's basically just the external DC in and the output. It's all self-contained, but some company designs and manufactures a complete range of these with a whole different bunch of voltage and current and power output capabilities. And you can, like, I found a price, one of this module in particular, the 20 volt 2 amp one, was like $17 on eBay delivered. And that's your entire bench power supply. It's ridiculous. So the one we've got here is, here's the manual that comes with it. It's in Chinese or English here. It's the DP20V 2 amp module. And this is a 4.5 to 23 volt input, which is great. So you could actually power it from a USB, power bank if you wanted to, any USB thing you wanted to. I haven't tried it that low yet, but I've just using a 12 volt 3 amp plug pack. But basically you can throw any plug pack. I mean, if you haven't got a whole bunch of spare plug packs sitting around from old laptops or any old gear or whatever, then, well, you're not really trying. So, yeah, you don't have to buy anything else, just the module and a couple of binding posts and a DC jack, and that's basically it. 0 to 20 volts output, 0 to 2 amps, maximum 40 watts. I am doubting that. I haven't actually tested it yet, but I am very much doubting it. Specs aren't going to set the world on fire in terms of peak-to-peak ripple. It's a switch-in converter, of course. It's not a linear converter. But, hey, for 20 bucks, like, you can't complain. This thing's great. And if you're not a fan of the real tiny display down here, you can get other ones like this one. I could actually power it up. This is from the, the same anonymous designer, manufacturer, whoever it is. If I find out who it is, I'll link it in down below. But this is input voltage range 6 to 40 volts. It's got a larger, a better looking display like this. And this one is a higher power device. We've got a larger heatsink. I'll show you the other one that I'm using. But yeah, this is a higher power job. But basically, voltage in, voltage out. Completely self-contained. These modules are fantastic. This one might be a little bit more expensive, but yeah, just choose your flavor. And here's another one. It's the DPS 3003 and adjustable in 0.01 volt steps, 4 to 40 volts. This one uses SMD parts. The other one was kind of through-holy. So if you, oh, there we go. Compare those two. So they're just available in all sorts of different versions. This one looks to be a little bit more high power, bigger inductor, bigger heatsink, bigger power trannies. This uses SMD ones, but even this one is very nice. They claim an output power range of 96 watts. Well, yeah, good luck 96 watts out of this output power, because I haven't measured the efficiency of this thing at all, but if you like assume like it's really fantastic at like 90% over the range, for example, then if you're delivering, let's say, in the order of 100 watts to your load, then this thing has to dissipate 10 watts. And, well, that's just not going to happen on a heatsink of that size with no airflow. But you can see that this one here can do 0 to 32 volts in 10 millivolts, 0 to 3 amps in 1 milliamp steps, and it's got 1 milliamp resolution, whereas the one I just whacked in the case here is only 100 millivolts resolution on the voltage and 10 millivolts resolution on the current, which is okay. And here's a look inside, and well, it's a bit how you doing. Some of those joints, it looks pretty crusty, but hey, what do you want for the money? You know, it may, like, it's gonna kind of sort of do the job. Meh. And bingo, just in a minute, I changed my supply over to the DPS 3003 supply. Is that the designer? And no, I don't know what that symbol is. Anyway, that's the model number. And we've got a much larger, colourful display here. Very, very nice. Now, I'm going to admit that the user interface on these is pretty terrible, but, you know, you kind of get used to it. Voltage set. Here, we've actually got to push the knob. Is pushable like this. Well, actually, so we can go up like that. We've got ourselves 5. Oh, there we go. Boom. And oh, how do we get out of there? There we go. And we can actually go down like this, and we can set our output current limit, of course. And you can set LED is just your LED brightness, and there's some presets if you want to do it that way. But it certainly is not the most user-friendly thing. But anyway, we'll switch that on. There we go, 5 volts, 0.993 amps, 0.999 on electronic BK Precision electronic load here, which is 0.005% class. So, you know, there's a little bit of error there on the measured current, but it's not too far off at all. So that's not too shabby. I like that. By the way, the output voltage is going to drop because of the leads there. I haven't got any remote sensing or anything like that, so don't worry about that. But that is very nice. Now, this DPS 3003 module is a little bit more expensive than this one here, which we had before, but not much. This was like $18 on eBay delivered. This one's like $23, $24 delivered. So, like, there's nothing much in it. I kind of like this one a bit better, but of course, this doesn't operate if you want to use it, say, for a 5-volt plug pack or something like that. This one won't be suitable. You've got to get the other module, which goes down to 5 volts. This is only 6-volt minimum input voltage. And anyway, this module only claims 0.5% plus 1 digit, which is, hey, more than enough for just a cheap bench supply like this. No worries at all. And there we are. We are able to draw up to the maximum 3 amps, and I'm drawing 3 amps from my constant current load there, 2.999, and we're getting 2.988. Readings a little bit out, but hey, that's doing that. So we'll actually get the thermal camera on the back of that and have a look. Well, I'll tell you what, I don't even need the thermal camera. We're delivering 15 watts here, and I can stick my fingers on the back of that heatsink there, and no problems whatsoever. It's barely even warm. So this sucker, at 12 volt input voltage with 15 watts output like that, is pretty darn efficient. I'm happy with that. Nice. Okay, I've had this running for a while at 10.91 volts output at 3 amps, and it's starting to get fairly warm, but I can still keep my fingers on that, so it's not up to 50. It's probably at, you know, the high 30s, maybe the low 40s there. But this is kind of the level at the sort of, you know, the 33 watt level, especially if you put this in a sealed case, you'd be looking at maybe having a little fan in there just to actually, and some vent holes to, you know, get some airflow over the heatsink fins in there and things like that. But, you know, that's a fair amount. You know, when you're powering projects, you're generally not going to do that from, like, just a simple plug pack type input like this. But anyway, the purpose of today's video is just to show you these little modules, not to actually characterize them and do everything else, because I'd need a different plug pack if I wanted to fully characterize this module, which is 96 watts. Oh. Anyway, I do like the secondary output display up here. It still shows the output when you're in the set menu. That's kind of cool. The knob does absolutely nothing when you're in the main display mode like this, which is good. Can't accidentally bump the output. And I also like that it shows the voltage input here coming from the plug pack. That's really handy. I probably prefer this module over the other one we originally saw with the multi-line display. It's just like, it's like bigger, color-coded. It's just kind of nicer. I'd go for this one. Anyway, if we have a closer look inside the DPS 3003 here, bottom is a display board in here. The top is obviously your main switching converter for your main switching trannies under here. We've got ourselves the big current shunt there. That's kind of neat. Which device does it use? I'd like to reverse engineer the circuit on these. And the main converter chip in here is an XL7005. Never heard of it. Comes from a company called XL Semi. I'll link in the data sheet down below, but that's only rated for 1.25 volt minimum output, as most converters are. That soldering's a bit how you do it, isn't it? Yeah, Frosty the Snowman. So yeah, I'm not sure how they're getting the the 0 volt output from that, but there you go. We've got a few miscellaneous other devices down there, and like I said, I'd like to reverse engineer. If anyone knows where you can get a schematic for any of these, and I'd love to know. Please leave it in the comments. Otherwise, yeah, requires a little bit of RE. And if you think these modules are a little bit wimpy and you want something better, well, you can try one of these bad boys. Here we go. Where are we? Digital buck boost power supply, 6 to 40 volts input, 32 volts output, 0 to 5 amps, 160 watts, maximum allowable input current, 10 amps, blah, 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 make sure higher than 18 volts, blah. Okay, so they've got some, once again, 0.5%, 1 milliamp output. Quite nice. So they've got the, but these are separate, so you actually get the module separate on here, and this one is, oh, there you go, it's the same sort of interface, but except it's on a cable, which then you hook up, you get the cable with it, by the way, and this one's about just over 40 US bucks, and this one's got the little mini fan on the back. So that's quite nice. You can actually mount that easily in a little case like I've got here. You could, yeah, that'd fit in there. That'd fit in there a treat. Look at that. So I could fit that in the little case I've got. So that looks really quite neat and jazzy, doesn't it? There's our output current shunt. We've got a couple of big trannies in there. Not sure what those ones, who are those caps from? Do we want to know? Anyway, nice little secondary board there. You got your micro powering the whole damn thing, but that is really quite nice. And it looks like there's 4 terminals on the inputs, 4 terminals on the output, and the little mini fan. It's probably as loud as buggery, but you know, whatnot. But hey, just these modules, the fact that you can get these in any flavor is just fantastic. I've got another one. Hang on. If you really want a bad boy, 0 to 32 volt output, 0 to 12 amps, DPS 3012. I might have to do a separate video actually building one. Once again, you get that and you get the board in there. Oh, look, dual current shunts down in there for that one. Forgive me for taking it out, but like little pissant fan on there for like, give me a break. 32 volt, 12 amp output capability with that kind of heat sinking. That's a joke. Right, but anyway, for the price, you're not going to complain. These things are just cute. Anyway, this one's rather interesting. We've got ourselves an ST Micro there running the show. There's our converter, is it? TI job, TL594 Classic. We can have a look around at some of the other stuff if you're the least bit interested. There you go. Got a couple of, they were a couple of MOSFETs, were they? Anyway, this looks like a rather neat module. Who's the brand on that? I'm not entirely sure. One hung low. Are they? Or are they Rome power transistors? Is that the R? There you go. 2 of them. They're doing a parallel jobby there, are they? Anyway, that would make a very interesting project. Maybe, like, you can always take those transistors off, mount them externally on a much larger heatsink, and actually turn that into a really neat project, because, you know, like 12 volt, like I don't really believe the specs on these things, but yet to be proven. But, you know, to have a 0 to 32 volt 12 amp supply, basically all done for you with the user interface and all the power supply control stuff, that, you know, for the price is just absolutely amazing. Just whack it into a case and have a suitable power supply, like a PC, modified PC power supply hooked up to it, for example. That'd do the business. So that might make an interesting project. I might give, you know, work on, put in, you know, you put it in a nice case and everything, do it properly and everything else. But yeah, I just like the concept of these modules, that you can get them in any shape or form for, you know, hardly any cost, and they might be a bit buggy or whatnot, and the performance probably isn't going to be great, and they're probably not going to live up to their specs or whatever. But the fact that they're so cheap and can make, you know, like a half decent power supply. Anyway, let's whack a scope up to this and see what's what. All right, let's power this thing up. I've got a 10 volt, I set a 10 volt output with a 3 amp load on our constant current load here. And let's switch the digital output on and we'll capture that. And that is as clean as a whistle. What's that, 500 milliseconds per division, 100 millivolt switch on? That's just fine and dandy. There's no overshoot whatsoever. It has overcurrent and over voltage set point protection as well. That's just a software thing. They're not doing that in hardware, but that's good. You can, you know, if you don't want to damage something, set it to, you know, 5.5 volts or something. You've got a critical board, 5.5 volts, and it shouldn't go over, but it's a software thing, so I wouldn't rely on that. Not as good as a hardware one. And something you don't see that often is a output power protection as well. I don't know, some people might need that. Okay, I've got the constant current set to 2 amps here, but I've got a 3 amp load. So let's just switch that on and see what happens. It should, yeah, 2 amps. There you go. We've only got 0.12 volts out, but we are getting our constant current 2 amps. It's limited that. All right, so that's going to be our bloody load here. Let's just set it, and we'll just short the output with the leads. That's better. These loads can be annoying sometimes. All right, so I just set 10 volts, 2 amp output, and we'll just short this puppy and see what we get. Hey, that's a nice clean response. Look at that. No worries. And let's see what response we get if we take it out of short and it goes back to 10 volts. That's pretty clean too. Don't mind that at all. And by the way, these are all step down converters. They're not buck and boost, so it's not like you can feed in 5 volts in and then get the other outputs. That's why this one only goes to a maximum of 11.26 volts, because we're only feeding in 12 volts. So if you want higher than that, then you have to go up. This is rated from 0 to 40 volts input. So if you want the 32 volts out, you've got to have at least 32 volts plus the dropout voltage in, because they're only a buck type device. Anyway, in constant current mode, I've had the output on that. I've had the output shorted at 2 amps on this thing for quite some time now, and that's not even warm. Not at all. So neat. And for those who want to see the switch-in noise, 65 kilohertz there. This is at 3 amps at 10 volt output, and well, it is what it is. You know, like just for a rough as guts power supply, that's just fine. You could probably add some extra filtering on the output if you really wanted to, but, you know, that'll do for a lot of projects. Let's just repeat that power on test with a 22 ohm load here, so we don't have the active electronic load in place. And we'll switch it on, and clean as a whistle. We'll just set the negative trigger there, and we'll switch it off, and bingo, that's a nice clean switch off in 50 milliseconds or so with that load, of course. It'll take longer if you totally disconnect the load, of course. And, well, that was a bit warmy. And then single shot switch it off. Of course, the output capacitance will take forever. So that takes about 400 and something milliamps. So if we set it to 300 milliamp current limit, and I've got 10 volt output, and I'll just give that a little whoop, switch on. There we go. That's actually the response of the constant current mode. So it it undershoots there in terms of the voltage, but that's okay. No harm done there, but it recovers, 50 milliseconds or so, so that's quite nice. And then if I set it to the positive edge and lift her up, there we go. That's the response going from constant current mode with the voltage limit there up to the 10 volts. And there's very little overshoot there. That's very nice. No problems. Of course, we haven't checked this over its full operational range, but that's a pretty good indication it's going to work like that over the full range though. So there you have it. These nifty little modules from company unknown, available from all and sundry on AliExpress and eBay and Banggood, wherever you want to get these things from. And they cost practically nothing, like this module's about $24 delivered or whatever, and you just have to whack in a plug pack of a suitably high voltage. Depends on what output voltage you're looking at for this thing, and the performance is probably going to be half reasonable. The UI is half reasonable, and geez, it's worth probably building one of these. They've found a real nice niche with these modules, I think. I don't think there's anyone else actually doing these. Whether or not it's one company making them all, or others have ripped them off and there's clones of whatever, I have no idea. But yeah, they've got a pretty nice little niche with these modules. I rather like them. There's more experimentation required. I'd like to fully characterize them, but that's a lot of effort for fully characterizing them over the input voltage range. I like various input voltage ranges for all the different output voltages, for all the different output currents, and get all the characteristic curves, and it makes my head spin just thinking about it. But they're probably going to give reasonable performance, so it's worth for the money. It absolutely cannot be beat. Just build it using junk bin, parts, a couple of binding posts, and an old plug pack you got lying around. Winner, winner, chicken dinner. Anyway, I hope you liked that. If you did, please give it a big thumbs up. And if you want me to do more videos on these modules, either, taking one of these big beefy ones and actually, making up a big beefy, 10 or 12 amp power supply or something like that, let me know in the comments down below. And as always, discuss over on the EEVblog forum. Catch you next time.